the world today is just awash in information, right?
Yeah,
And frankly, so are our AI models.
that's true. There's so much data out there.
Yeah, and asking an LLM a really complex question, it often feels like it's just, well, skimming the surface. Quick answers? Maybe, but not always that deep, verifiable understanding.
Mm.
We're talking about a new frontier here. They're calling it deep research. It's about how AI can truly, comprehend, break down, and then synthesize knowledge from all these different sources.
It's a fascinating area.
Okay, let's unpack this then. Today, we're diving into InfoSeek. It's this groundbreaking framework that's teaching large language models to do more than just retrieve facts.
To think more like a researcher.
Yes, offering you, the listener, a genuine shortcut to being truly well-informed on even the trickiest topics.
And what's really interesting here is that deep research, for LLMs anyway, it isn't just some catchy phrase. It's actually a precisely defined set of tasks. It demands that the model decompose a big question into smaller, manageable subproblems. That requires multi-step reasoning.
Right.
And then synthesizing verifiable evidence from multiple, sometimes even conflicting sources. It's fundamentally different from, say, traditional question answering,
Which is often more like a direct lookup.
or maybe a single inference step, yeah. Much simpler, relatively speaking.
So to really get what deep research involves, maybe it helps to compare it to problems we're already sort of familiar with in AI. How does this change how models need to think?
That's a good way to look at it.
Yeah.
We can classify some fundamental problem types to see the distinction. Think about a constraint satisfaction problem, a CSP.
CSP. Okay.
This involves finding a unique answer by satisfying several independent conditions, like a little detective game.
Give me an example.
Okay, imagine asking, who got a PhD from Princeton in 1938 and was born in London and graduated from Cambridge?
Okay, 3 separate facts.
Right. Independent constraints. You intersect them, and the answer pops out. Alan Turing. All conditions have to be met, but they don't depend on each other in sequence.
Parallel constraints. Makes sense.
Then there's a multi-hop problem, or MHP. Now, this one does demand a sequence of dependent inferences. It's more like a trail of breadcrumbs.
Okay, sequential.
For instance, which country's capital was the birthplace of the scientist who solved the Enigma code?
Ah, okay, I see the steps.
First, identify the scientist Turing. Then, find their birthplace, London. Finally, identify the country of that capital, England.
And if you mess up step 1.
The whole thing falls apart. Each step relies on the previous one being correct.
Right. So where does deep research fit?
That's where the hierarchical constraint satisfaction problem, or HCSP, comes in. This is how deep research questions are formalized. And it's a real step up in complexity.
How so?
It goes beyond just CSPs or MHPs. It involves a hierarchy of interdependent constraints. It intertwines both parallel conditions, like in CSPs, and sequential steps, like in MHPs.
So it's combining both types of complexity.
In a structured, hierarchical way. Think of it like navigating a complex decision tree or knowledge tree. The solution only emerges by progressively resolving this hierarchy of sub-questions.
A research tree, as the paper calls it.
That's right. For questions with unique, verifiable answers, you can map the reasoning path onto this tree structure. It really forces an LLM to perform complex reasoning.
That definitely sounds incredibly challenging for an LLM. So if models have gotten decent at CSPs and maybe MHPs, why do the existing training methods and datasets, fall short for these HCSPs?
That's the core issue, isn't it? Why aren't current benchmarks sufficient? You look at datasets like, say, natural questions or HotpotQA.
Which are pretty common, right?
Very common, and valuable for single-hop and multi-hop QA, no doubt. But they often fail to capture that real structural depth needed for deep research.
How do they fail?
Well, they might accidentally allow for shortcut reasoning. The model finds a trick to get the answer without really following the intended complex path. Or there's knowledge leakage, where the answer is kind of hinted at elsewhere.
So they lack that true hierarchical complexity.
Often, yes. And particularly in the open source world, there's been a real lack of high-quality, large-scale data sets specifically designed for these multi-layered deep research scenarios.
Okay, so that gap in high-quality training data is exactly what InfoSeek is trying to fill. If the existing stuff isn't cutting it, how do you even begin to create problems that are complex enough? What's InfoSeek's approach here?
InfoSeek is essentially a data synthesis framework. It's designed to generate these structurally complex HCSPs automatically and, importantly, scalably.
Automatically. How?
At its heart is a dual-agent system. These two agents work together recursively to build that research tree we talked about, using large-scale web pages and Wikipedia as their source material.
Like automated knowledge architects.
Kind of, yeah. You have the planner agent. It keeps a global view of the tree being built. It decides what needs to happen next based on the desired complexity, like do we need more sequential steps or more parallel constraints?
Maintaining balance.
Right, ensuring balanced growth. Then you have the browser agent. It's the one that actually does the work based on the planner's instructions.
The legwork.
It searches the web pages, finds potential hyperlinks to add depth, or extracts specific claims to use as constraints, and crucially, it validates their relevance.
Making sure the info is sound.
Yes.
Yeah.
So this research tree becomes the blueprint. The root is the final answer, the internal nodes are intermediate subproblems, and the connections, the edges, represent the logical dependencies.
Okay, so it builds this intricate knowledge structure, the blueprint, but how does it turn that structure into a question a human or an LLM can actually read and try to answer while keeping all that complexity intact?
That translation step is key. InfoSeek uses a sequence of actions not just to build the tree, but to ensure the resulting question forces deep reasoning.
What are those actions?
Okay, first, initialization. The browser picks an entity from Wikipedia, or the web, so that'll be the final answer, the root of the tree. Then it adds a related entity as a child to start things off.
Simple start.
Then, action 2 is blurring with constraints. The planner finds a spot in the tree where the current clues aren't quite enough to uniquely pinpoint that intermediate step or entity.
Making it harder.
Right. The browser then goes to that entity's web page and pulls multiple related claims, adding them as child nodes, as constraints. This blurring prevents what they call overdetermination.
Meaning you can't just solve it with one lucky clue.
You got it.
Yeah.
It forces the model to consider multiple pieces of information. Then action 3 is extending the tree. This is about adding depth, more sequential steps.
The multi-hop aspect.
The planner targets an existing entity node for vertical expansion. The browser finds a relevant hyperlink in its article representing a dependency and creates a new child node from that linked page. More steps needed.
Okay, building layers.
Finally, termination and question generation. Once the tree hits the target complexity and all the nodes have enough constraints, they use a powerful LLM, like DeepSeek v3 or GPT 4.1.
A generator model.
Yes, to generate the actual natural language question, and is prompted specifically to create a question that requires navigating the entire tree structure.
Ensuring it really tests that deep, multi-step reasoning and leads to a unique, verifiable answer.
That's the goal.
That's a very clever process for controlling complexity. But like we said, complexity isn't everything. You need quality, reliability. How do they make sure this generated data is actually trustworthy for training?
Absolutely critical. They use a strict two-part quality assurance protocol versus the difficulty criterion.
How do you ensure it's not too easy?
Right, and specifically not solvable just from the LLM's existing parametric knowledge. They want it reasoning, not just recalling. So they tested the questions on a strong baseline model, Quinn 2.53D2B-inst.
Oh.
It only got 2% right directly, and any question it did get right, they removed it from the data set.
Wow, okay. So definitely challenging. What's the second check?
Verifiability. This confirms two things. The question is factually grounded, and it is actually solvable using the provided web sources. They use the Gemini 2.5 Flash API for this.
How does that work?
It tries to derive the answer using the ground truth web pages, but crucially, these are mixed in with distractor documents.
To make it harder to guess.
And to ensure there's a clear path. This step filters out ambiguous questions, or ones that are underdetermined where there isn't a unique findable answer in the sources.
So difficult but solvable and fact-based.
That's the combination they're aiming for. And the scale is impressive, over 50,000 QA pairs, 16,500 reasoning trajectories, all curated for just over $570.
That seems very efficient. And does it work? Is the dataset truly hard?
Well, they tested another strong baseline, Quinn 2.572B, on it. It still had a 91.6% overall failure rate. And the failure rate went up as the trees got more complex, which shows the framework controls difficulty well.
Okay, a massive, high-quality dataset designed for deep research. That must lead to some pretty interesting results when you actually train a model on it. What happens then? What's the model structure?
Right, so the model framework built on this data is called InfoSeek. It's designed specifically for this kind of advanced agentic search and deep research. It has a novel workflow and a two-stage training process.
Let's start with the workflow. What's different there?
It tackles a common problem, context bloat. You know, when search results just overwhelm the model.
Too much information.
Yeah. So InfoSeek starts with a dedicated thinking phase. The model actually plans out its steps first.
Like a human researcher might outline their approach.
Sort of, yes. Then it uses parallelized multi-query research. Instead of one query at a time, it sends out multiple diverse queries simultaneously.
To get broader coverage faster.
That's the idea.
Yeah.
Wider net, more relevant info, hopefully.
Mm.
And then there's a key component, a dedicated refiner agent.
What does that do?
Think of it as a research assistant. It takes the top search results, sifts through them, pulls out the most crucial bits, and condenses them into concise summaries. It uses a smaller model, Quinn 2.57b inst, for this.
So it keeps the working context tight while preserving the important info?
Exactly that. Hierarchical, compact context helps the main model focus on reasoning.
Okay, interesting workflow. What about the training?
It's a two-stage process. First, supervised fine-tuning, SFT. They use rejection sampling here to build a data set of successful reasoning trajectories from the InfoSeek data paths, where a teacher model got the answer right.
Focusing on good examples.
Yes, filtering for high-quality, executable paths. Then, after SFT, comes reinforcement learning, RL,
To further improve.
to enhance the reasoning and search skills even more. They use an algorithm called Group Relative Policy Optimization, GRPO. The reward signal is simple. Did the model get the format right and extract the correct final answer? Yes or no?
Binary reward. Did it work or not?
It pushes the model to learn effective strategies for navigating these complex problems.
So the big question. Did all this intricate design, this special data set, this workflow, this training, did it pay off? How did InfoSeeker actually perform?
The empirical results are quite striking, really impressive.
Oh, yeah.
On the BrowseComp-Plus benchmark, which is known for being tough, open-ended, requiring lots of search and reasoning, InfoSeeker 3b.
That's the 3 billion parameter one, right? Relatively small.
Yes, quite compact. It significantly outperformed much larger models, like 32 billion parameter ones, Quinn 332b, for example. It even did better than some lightweight commercial APIs like Gemini 2.5 Flash.
Oh.
Its performance was actually comparable to stronger APIs like Gemini 2.5 Pro, which really highlights how effective this approach is for getting deep research capabilities into smaller, more efficient models.
That's huge. A smaller model punching that far above its weight.
It really is. And it wasn't just that benchmark. InfoSeeker also showed strong general agentic search capability. It consistently outperformed other methods, both standard ARG approaches and other agentic search models, across a range of single-hop and multi-hop QA benchmarks, too. It seems to generalize well.
And did they check if the InfoSeek data itself was the key?
They did. Comparative experiments showed that training specifically on the InfoSeek dataset led to substantially stronger deep research performance and better use of search tools compared to models trained on those more common datasets like NQ and HotpotQA.
So the data really is the secret sauce here.
It strongly suggests that purpose-built, structurally complex data is vital for teaching these advanced reasoning skills.
That's incredibly impressive. It really drives home the power of focusing on the data's structured, rigorously designed data for training LLMs to handle genuinely complex tasks.
So just to wrap things up, InfoSeek provides this data-centric framework. It formalizes deep research using these hierarchical constraint satisfaction problems, setting them apart from simpler tasks.
Right, defining the champ.
Then it operationalizes this with that scalable dual-agent system for building the research trees, controlling complexity, and ensuring quality.
And the payoff is clear. Models like InfoSeeker, trained this way, show really robust reasoning, great tool use, and outperform strong baselines, even much larger models. Plus, it's great that the codes and datasets are open source.
Absolutely. It encourages more research, lets the community build on this. What really stands out, I think, is that this work feels like a clear step towards LLMs becoming more than just conversational partners, moving towards being, autonomous knowledge engines.
Capable of handling these complex, verifiable reasoning tasks on their own.
The focus on structured data, on that meticulous construction of problems.
Yeah.
It seems to be changing how we approach teaching AI to really understand and work with knowledge. It points towards models that can genuinely navigate information in a more human-like hierarchical way.